Many of you are probably familiar with USB PD or power delivery. This is part of the wider USB specification, specifically focusing on powering high-draw devices, like phones and laptops, via the ubiquitous Type-C interface. The basic operation of power delivery is fairly simple. When we first plug in our device, it's supplied with 5 volts and presented with a menu by the upstream device. This menu contains a tasty selection of voltage levels and maximum currents for each. The load device then simply picks from this menu and shortly after receives the desired supply. This process is known as negotiation, and using this handy breakout board and this so-called trigger board, we can watch it happening in real time. Here's the 5 volts when we initially plug in our cable, and then we can see some action on the data line, which is some intense negotiation taking place. And then finally we see the voltage ramp up to the 12 volts that we want. And this is power delivery. With its selectable voltages and high power capability, it's great for powering pretty much anything. But what's this got to do with car chargers? Well, if we take the example of a smartphone, this contains a battery, likely a single lithium cell. Its voltage will range from about 3 volts when it's dead, up to 4.2 when it's fully charged. Because power delivery only supports a few discrete steps in voltage, a DC to DC converter is required inside the phone to convert whatever it's receiving from the supply to whatever the cell needs. This converter takes up precious space inside the phone, and it also generates heat while it's running, which, being located near the battery, also heats that up, shortening its life. This is just like an OBC or onboard charger in an electric car. The conversion to match the voltage of the battery pack is carried out within the vehicle, which is great for charging pretty much anywhere with a mains supply, but is not so good for charging quickly. A typical OBC can charge a car at up to 11 kilowatts. If you want more than that, you'll need to find a DC fast charger. These are external to the car, so can be much beefier. This relatively low power 50 kilowatt BP charger can output anything between 200 and 500 volts at up to 125 amps. And the trick with these is that they connect directly to the car's battery pack. No internal conversion required. This is the secret to super fast charging. In 2017, the folks at the USB Implementers Forum succumbed to their jealousy and introduced PPS or Programmable Power Supply, a standard allowing fine adjustment of supply voltage and also a constant current mode. Power supplies supporting this are essentially just miniature DC fast chargers, bypassing the phone's internal DC to DC converter, which we could call the onboard charger, and connecting directly to the battery. While this may improve overall efficiency a little with one less conversion process, the main appeal of this is that without the internal converter, less heat is generated within the phone, making the battery cooler and therefore happier, and also opening up the possibility for more heat to be generated by the battery itself, meaning faster charging. A nice example of this is the Samsung Galaxy S23 Ultra, which, according to some of the internet, will charge in about an hour and a half at up to 18 watts with a standard PD charger, but that drops to an hour at up to 45 watts when paired with a PPS capable charger. We can see PPS in action using the PocketPD from CentyLab, which is essentially a breakout, giving access to the USB's V-bus connections, as well as providing a nice user-friendly interface to set voltage and current. Many of us already carry PPS-capable chargers with us everywhere we go, and a PocketPD is all you need to turn it into a portable lab power supply. And with no actual power conversion taking place, there's no need for heavy magnetics, making the PocketPD very light. I've already been saved by mine several times when out and about, and now take it everywhere with me. Let's use this to charge a lithium cell, just like how a smartphone would. First of all, we're going to set our voltage to 4.2 volts. This is the maximum voltage the cell can take, so we don't want to charge above that. Then it's time to set the charging current, which in this case is going to be 4 amps. Now all we have to do is turn it on to charge the cell in our phone without any additional circuitry. And in case you're wondering, this is what happens when you try to connect directly to a battery with standard power delivery. With no current limiting capability, the supply simply trips and turns off. An interesting source of additional complexity for power delivery is that the cables are not fixed to the chargers, and not all cables are born equal. Because of this, all Type-C USB cables that support power delivery need little chips at either end to communicate to the device they're plugged into, letting it know how much voltage and current the cable can handle. Of course, this particular feature isn't required for EV chargers, where the girthy and very costly cables are fixed to the charger they were intended for. And that's it, quite a quick one today. Hopefully you found this somewhat interesting. If you like the look of the PocketPD, Check it out using the link in the description. And with that, thanks for watching. Bye!